hope everybody had a great long weekend, and I hope you're all ready to start our getting ready for 6th grade material. So this is lesson 1, and like I said in the posts, we're going to have one lesson each day, which is pretty much like almost the same as what we've been doing in our textbook. It's just a little shorter, with a share and show section and an on your own section, and usually a problem-solving problem. And then there's going to be a separate practice page for you, which we are going to use for homework. Okay? So today what we're going to start off with, the first lesson, is comparing fractions and decimals. So this lesson is building on the decimal and the fraction concepts that you've learned in 5th grade, and it's going to prepare you for comparing decimals and fractions, which is taught next year in 6th grade. Okay? So let's begin. The Unlock the Problem for today. The Tech Club compared the weights of 3 cell phones. Esteban's phone weighed 4.7 ounces. Jill's phone weighed 4 3/5 ounces. Mona's phone weighed 4.35 ounces. Who has the phone with the lightest weight? So one thing that we can do is we can use a number line to compare fractions and decimals. So this is something that we look at a lot in 6th grade. And certain things that you want to remember. The larger values on a number line are further to the right, and the smaller ones are further to the left. So what we can do is locate benchmarks, okay? So we learned about benchmarks when we did decimals. We talked about quarters, if you recall. 25 cents is 1 quarter, 50 cents is 2 quarters, 75 cents is 3 quarters. So if you recall, that's what they look like here. So 4.25 is 4 1/4, which is the same as 4 1/4, right? 4.5 is the same as 4 1/2, and 4.75 is the same as 4 3/4, right? So if you take a look at your number line, we're starting down here at 4 and going all the way up to 5 here. And we want to try to, as accurately as possible, compare these 3. So what we've done here is we're looking at, this is broken up into fourths. So this is 4 1/4, which is the same as 4.25, okay? Now what we're doing is we're breaking this up. I'm so sorry. We're breaking this up into even smaller pieces here. So then we have over here 4.5, 4.75, and then 5. So what you want to try to look at is how are these broken up, okay? So sorry, see, keep on having to clear my throat. So if you look, we have 1, 2, 3, 4, 5, okay? So that means that these are broken up by 5s. So we have 4.05, 4.10 or 4.1, 4.15, 4.20, and then 4.25. Next would come 4.3 or 30, 4.35, 4.4 or 4.40, 4.45, and then 4.5. Okay, so you can see it's just going by 5s. And then this would be 4.55, and then this is 4.6 or 60, which we're seeing is equivalent to 4 3/5. We'll talk about that in a second. And then 4.65, 4.7, 4.75, and so on. Okay, so I'm only not going further than this because that's the largest that we have here up here. Okay, so we're trying to compare 4.7, 4 3/5, and 4.35. Okay, so step 2 is to mark the weight of each cell phone on the number line. Now that we have a number line here, we're going to find the location of all of these. So how do we figure out that one 4 3/5? You might be thinking, how did you find that? Because I wrote everything out in decimals. So don't forget, that if this is broken up into into fifths, you can figure out each of those as a fraction with a denominator of 5. So it's like 4 and 1/5, 4 and 2/5, 4 and 3/5, and so on. But of course, the 4 and 3/5 is over here. So what we want to look at, not here, sorry. So what we want to look at first are the decimals. They're going to be the easiest ones to place because we wrote it out before using decimals. So let's find our 4.7, and here it is, right here, 4.7. It's already been written there for us, so I'm just going to darken it. I'm going to skip over the 4 and 3/5 for a second, and then I'm going to find the 4.35 for you, which is here. Okay. And now we have to discuss how do we find where the 4 and 3/5 is. So to see where that 4 and 3/5 fits in, what we're looking at here, okay, if you notice what these are broken up by is basically 5/100ths each, right? So just to show you how I'm leading up to this, the 4.05 here is really 4 and 5/100ths, right? So 4 and 5/100ths is really like 4 and 1/20th, right? So each of these little dashes represents something much smaller. This is 4 and 10/100ths, right? And that would be 1/10, 4 and 1/10 when you reduce it, okay? And so on. So every time, all of these decimals are going over 100, right? So when we got to this spot, we had 4 and 60/100ths. So if you look at it that way, okay, you can also look at it as getting rid of the last 0 on the end, so it's 6/10, right? And 6/10 reduced to 3/5. Okay, so that's how we can find where the 4 and 3/5 is. So now to order from who's got the lightest phone, we can see you look from left to right. So the smallest or the lightest amount is going to be furthest to the left. So that's the 4.35, and that was Mona's phone. So it's Mona's. Sometimes I like to label it so that I can see before I write my answer. And then the 4 and 3/5 was Jill. And then the 4.7 was Esteban. Oh, that's an E. Okay. So they want to know who had the phone with the lightest weight. So the lightest weight was Mona's, right? And that's how you get the answer. Okay. So let's take a look at one for us to do ourselves. Okay. We're going to compare 1/5, 5/8, and 2/10. Okay. Remember that being able to say your decimal the proper way will help you to place things on the number line, and it'll help you to compare in the future. So let's see which number has the greatest value. Well, let's take a peek at what goes on here. First, we're going to mark each of the values. So 1/5. Okay, as you can see, this is broken up again. We have 0.25, so what you have to figure out is how is this all broken up? So this is 1/4, right? 1, 2, 3, 4, 5. So again, like before, it's broken up into 5 pieces. So this is 0.05 here. And this is 0.10, 0.15, and that would make this 0.20 or just 0.2, right? So now that's the same thing as 2/10, right? 2/10 is 1/5. So what you notice is that the 1/5 and the 2/10 are actually equal. They're at the same spot. Now let's check out the 5/8, right? So how are we going to find the 5/8? We have to figure out which decimal is going to be equivalent to 5/8. It's over here, so we have to figure out how that would have gotten there, right? So let's take a peek. You don't even have to really worry too much about this part because we know it's going to be the highest value. It's the furthest to the right, but let's just look. This is 0.5, so this is 0.55, 0.6 or 60, and then this is 0.65, right? So halfway between there, we have to take a look and see how can we figure out that 5/8 is there Okay, now this is all out of either 100 or out of 10, so you're trying to figure out how you could write an equivalent fraction there. So if we're halfway between 6 and 6.5, 60 and 65, that would be 62.5. Okay, so this is a little too confusing for us to really do quite yet before we're doing the 6th grade. So for now, we're just going to look at where these numbers are placed and just know that if it's further on the right, then that means it's the greatest value. Okay, and we'll talk more about how to actually place that more in detail. Okay, so we're going to do the share and show now. We're going to identify the points on the number line and then say which one's the greatest. So first for point A, we can already just look at this and see which one is going to be greater. Further to the right is A, so that's going to be our greater. But we're going to look first at what point A is as a decimal. So you have to look at the dashes between and see how this is broken up. Okay, just like before, you can see there's 1, 2, 3, 4, 5. So each of these is broken up into 500ths here, like this. Okay, so if you want to even go through and label the whole thing, you can, if it's helpful to you. Okay, keep going. Okay, so here I can now see that point A is 0.70 or 0.7. Remember, those zeros, they don't really matter. So this is 0.05, but this is really 0.1, 0.15, 0.2, 0.3, and so on. So 0.7 or 7/10. Okay, so that's 7/10. Now point B as a fraction, 25 hundredths is 25 hundredths, but hopefully we also remember that that represents a quarter, which is 1/4. So if we reduced our fraction, it would be equal to a quarter, right? So now we're comparing these two. We don't even have to look at anything else, but we can just see further to the right is point A, which means that 0.7 is greater. Okay? All right, so now what we're going to do is we're going to take a look at lists of numbers, and we're going to use our number lines to answer the question. So we have to make our own number lines here. Okay, so you can choose how you'd like to break it up. My suggestion is going to be to follow the way that it's been done already. Okay, so let's set up our number line together. So we're going to follow basically what we've been doing before. So let's break it up by 5s. 1, 2, 3, 4, 5. And that will be our 25 hundredths area, which is the same as 1/4, right? So you want to label that basically as soon as you remember. And anything else that you want to label, if you know this one is 1/10, you could even put that in. It really doesn't matter. Whatever you want to label, you can. This is 0.2 here, right? Which is 2/10 or 1/5. Okay, so the closer you get to these numbers, the better, right? So now we're going to go another 5. 1, 2, 3, 4, 5. And that's our 0.5, which is the same as a half. Okay, and we have 0.3, 0.35, 0.4, which is the same as 4/10, right? 4/10 is equal to 2/5, and that's one of the numbers that we need. So it's good to try to label things before you go. Okay, and then we have 0.45. Okay, 0.5. If you notice, we need to go up to 0.55, so we still need to keep going. 1, 2, 3, 4. 1, 2, 3, 4, 5. And that's my 0.75, which we know is 3/4. Okay, and then that would be 0.55, 0.6, and so on. Okay, so you can kind of label as you go and then start to put the numbers where you need them. So 55 hundredths 0.55 is 1 to the left of a half, so that's 1. My 2/5 I found already by doing where 4/10 was, which reduces to 2/5. So it's right here by 4/10. And then 0.46, let's take a look. We don't have it labeled here, but I do know it's going to just be a little bit to the right of 0.45. So it's going to be approximately here. So the number with the greatest value is going to be the one that's furthest to the right, so that's 55 hundredths. Okay, and that's it. All right, so for the on your own, I'm going to have you guys pause this and try it out yourself. Before you do that though, I'll help you set up the same number line. You can really just use the same number line for all of these really. Okay, if you see a need to change it a little bit, you can. So before you go and try this on your own, we can maybe set it up together. But I would just follow the same way that we did it before. So you break it up into 5 pieces, 1, 2, 3, 4, 5, which is your 1/4. 1, 2, 3, 4, 5, that's 1/2. 1, 2, 3, 4, 5 is your 3/4. 1, 2, 3, 4, 5 would be your whole. Okay, so go ahead and give that a shot, and then try the other two as well. Use the same number line, and you can do what I did before and label it as you go if you want to. Okay, so try these and then unpause and check your answer. Okay guys, so for number 4, you should find that the greatest value is 3/4. This one was kind of easy. It's all broken up perfectly for you. All you need to be able to do is say, this is 4/10, and if you need to reduce it, that would be 2/5. Actually, in this case, you didn't even need to do that. I forgot. It's already written as a decimal, so ignore that. What I meant to say here was the 3/4. As long as you remember to label your 0.75 as 3/4, you'll be able to find it quite easily. 15 hundredths. So 5, 10, 15. Okay, right there. And then the 4/10 is over here, and the 3/4 is the highest one. For number 5. Okay, these could be a little trickier if you weren't good with your decimals during the year, and mixed numbers. I wouldn't worry too much though. For number 5, we can see 2/5. What I tried to show was if we're looking at out of hundredths and tenths here, we learned we can change the denominator. We multiply them both by 2, we'll get the 10th. So that would be 2 4/10, right, which is the same as 2.4. Okay, so 2 2/5 is 2.4, so that's over here. 2.45, it's already written at, oh, by the way, I'm sorry, for this one you follow the same scale, but we're just putting it between 2 and 3 instead of 0 and 1 because these are all mixed numbers with 2. So it's still broken up into 5s. 2.05, 2.10, 2.15, 2.2, 2.25, and so on. And so right after 2.4 comes 2.45, right? And there it is. And then finally, the 2 2/3. If you weren't able to figure that out on your own, the 2/3, what you can do is you can look at the number 2/3 and 2/5, and you can see that 2 is closer to 3 than 2 is to 5. So you know this is a larger fraction. Okay, so even if you weren't able to place it exactly on the number line, you can say, that it's bigger. Okay, excuse me. Okay, so number 6, 3.95, 3 5/6, and then 3 4/5. So again, the 3 4/5 you can change into 3 8/10, which is 3.8, and 3.95 is all here, and then the 3 5/6 is almost the same as 3 4/5, almost the same. It's just slightly bigger, but it's not going to be bigger than 95 hundredths. So the 3.95 is the largest one. Okay. So that's it for this lesson. For your homework, I suggest that you draw the number line, the way that we did it in class. Just make sure that you're careful if you're having mixed numbers that you start with that number and put these fractional pieces in between that number instead of 0 and 1. Okay? So I know it's a little bit tricky, but you'll be fine. And when in doubt, remember the ways that we learned during 6th grade to convert a decimal and a fraction. If you need a review on that, let me know, because I do have some materials. Okay, and that's it. So have fun.